Hi, everyone. This is a video that I'm going to make answering some questions that came up about solving radical equations. So this is a radical equation. I'm just going to write that. Solving radical equations. So when we have a radical equation, we have this symbol here, which we call the radical sign, and we're trying to figure out how to isolate x. So we want to undo everything and solve for x, and thus we'll get x by itself. So if we want to undo everything, the opposite of taking this, what we call the fourth root, because that index is 4. If we want to undo an index of 4, the opposite of taking the fourth root is to take the fourth power. So I'll take the fourth power on both sides. And by the way, this is everything that you did in the person who sent it, the question numbers for section 7.4 in Math 65, number 31. This question that you sent, you had done all of the work correctly. So let's just go ahead and review what you got. So then after we take the fourth power of the fourth root, we get 3x minus 2 equals, let's see, negative 3 to the fourth power means negative 3 to the fourth means I'm going to multiply negative 3 because the negative is inside the parentheses, because I'm taking the fourth power of that whole side. It's going to be negative 3 times itself 4 times. And so this gives us 9 times 9, which is 81. And so that's a positive 81. To solve now for x, because we have the radical gone, which I like to change colors, we have the radical sign cleared. To get x by itself, we can undo everything. So we can add 2 to both sides. We get 3x equals 83. And then we can divide both sides by 3. So we get x equals 83 thirds. And then I have to ask myself, does 3 go into 81? There's actually a trick for that. If you add 8 plus 3, you get 8, 9, 10, 11. If 3 were to be able to go into 11, that's the sum of the digits. If that was a multiple of 3, which it's not, 3 doesn't go into 11, but if it were, then it would be divisible by 3. So we can't reduce it. In other words, we can't reduce the fraction. So this seems like a legitimate answer, and we might go ahead and put 83 thirds into set notation, but wait, we can't yet do that because we need to check. So the instructions here will be sure to say solve and formally check. That means you're going to take your solution that you found and plug it in for x. So when we do the check, it's going to look like this. I'm going to take the fourth root of 3 times 83 thirds minus 2. And we're going to set that equal to, or we might just draw a line in the middle so we don't assume that they're going to be equal, but that might be equal to negative 3. And now I wouldn't be solving for x anymore. I'm actually plugging it in, evaluating to see if it works. The cool thing here is that even though this is a kind of a gnarly fraction, the 3's actually cancel. So I get the fourth root of 83 minus 2. And then that's going to be the fourth root of 81, which is 3. But hey, wait a minute, it's supposed to be negative 3. So the truth of the matter is you did everything correctly to solve, but you have to check it because sometimes you have a situation that's impossible. In fact, later on in the term, we're going to actually be solving these things graphically. And that's going to look like setting one side of the equal sign equal to y and the other side equal to y and looking for those points of intersection. Well, it turns out there is no point of intersection. Since there's no solution, it didn't work out. We can erase this here and we replace it with an empty set. An empty set means no solution. Okay, so the important thing here and the thing that was missing, you had done everything correctly except for you want to just make sure that you check. Okay, then there was another question that got sent to me, and that was from the midterm review. And this one is quite a doozy because when you have, this is still a radical equation. We are still going to solve and check. We know it's a radical equation because you have these square root symbols in here. Now, when you have one, I just put a little hook on the end so that I would make sure to realize that that -3 here is not underneath the radical. So when you have these square roots along with other numbers, which we call constants, they have no variable, right? You're going to have to actually FOIL. And so that's going to introduce a whole other radical expression. So let's take a look at how that might work. In the problem that I got sent to me, the first step that you did, and I would be really careful here because the biggest mistake that people make is with positive and negatives. So the first thing you did was I knew that you added 3 to both sides because I saw you got 7 minus the square root of m plus 7. And then over here, that helped isolate that square root of m. Now we are going to solve for m, so we're trying to get m by itself, but m's a little bit all over the place. In order to undo this radical, we can, well, the inverse of the square root is the square. So I'm going to square both sides. And when you square both sides, the thing that people will often forget, they'll square sometimes the 7, and then they'll square this square root. On the second side here, they'll square both of these, but they would forget that you need to FOIL it. Here, when you take the square root of m and you square it, all you're left with is m. But the problem over here is that you're going to have 7 minus the square root of m plus 7 times itself, 7 minus the square root, of m plus 7. And so when you try to FOIL that, when you try to square that, you're going to need to FOIL. So we're going to do first, the first is going to be 7 times 7 or 7 squared. So that's 49. And then from here, you would have -7 times the square root of m plus 7. And then another one of them, because you have this negative sign here. It's negative sign here, negative times a positive 7. You can see that. That's the inside is going to be another -7 square root of m plus 7. And then in the end, you have a negative times a negative. That's a positive and a square root of m plus 7 times itself. So that's squared. And it would be negative times a negative. So you could even have a negative in here squared. I already did the negative times a negative, but if you include that negative in the squaring, it will be a negative times a negative. So let's see what we get then. Oh, and we don't forget about m on this side. So that introduced a whole other set of radicals. What we can do is simplify from here, and then we're going to need to actually isolate the radical in order to square again. So from here, we have m equals 49. Now these are alike, and that's because this radical expression here is exactly the same. So if you have -7 of these and another -7 of these, you have -14 radical m plus 7. And then in the end, the negative times the negative squared is going to be a positive m plus 7. The square root went away there because you squared it. I know this is a very complicated problem. I sent another example too, but just take some practice. So now what do I want to do? I want to be able to gather up all of the like terms and get everything over onto the other side so that I can isolate this radical. That's the name of the game. Isolate the radical. So how can I do that? Well, one thing I can do, and this is where I would show all of these steps, okay, is we had a negative squared, so we got a positive here, so that's why we have to be careful of the signs. So if I want to get rid of that m, I'm going to subtract m. Oh, how convenient. I subtracted it from both sides. Now this m minus that m, that's 0. Okay. I have 7 plus 49 on this side. These are what we call like terms right here. The 7 and the 49 are both constants. So if I want, I can subtract them both from both sides. So I'm going to be subtracting 49 on this side and 7. And the m's already canceled. So now, oh, what happened? Go away. Done. Okay, so let's see what we have. The m's minus m minus m, these cancel out. That's 0. Negative 49 minus 7. I got more negative. And what is 49 plus 7? Is that 56, right? Negative 56 equals negative 14 times the square root of m plus 7. That's all gone. This is 0. This is 0. Okay, I still want to get that radical by itself. So let me go ahead and how can I isolate that? Well, what action is happening between the negative 14 and the square root sign? In between, there's an implied multiplication. So we can divide both sides by negative 14. And let's see, what do we get? Well, 7 goes into both. That's a negative divided by a negative. 7 goes into 56, I think, 8 times. And then 7 goes in here twice. So I could reduce that down to, if I divide this by 7, divide this by 7, actually negative, I would get 8 over 2. Oh, which is actually conveniently 4. That's equal to the square root of m plus 7. Oops. Square root of m plus 7 is equal to 4. Okay, so now how do I get rid of this square root? I'm going to do the opposite. And I have to do the same thing to both sides. So the inverse of the square root is the square. So I'm going to square both sides. Whatever I do to one side, I have to do to the other. So here I get 16 equals m plus 7. I can subtract 7 from both sides to isolate m. And that should be 9, I believe. Is that true? No. Yes, that is 9. Okay, I just really think about that. And you could use a calculator too, but we don't know if this truly is the answer unless we check it. So to check it, we're just going to take the exact same equation, square root of m minus 3 equals 4 plus, and instead of the equal sign, I'm actually going to draw a vertical bar between them because I don't want to necessarily say that they're equal. And then minus the square root of m plus 7. Now, what I was meaning to do is plug the 9 in for m. That's what I meant to do, but I was just writing the problem down. Oops. So now I get the square root of 9 minus 3 over here, which is 3 minus 3, because the square root of 9 is 3. That's 0. And then over here, I'll have 4 minus the square root of 9 plus 7. And that's 4 minus the square root of 16. 4 minus 4 equals 0. So since 9 worked out, I can put 9 in set notation. Did I do all of that correctly? I hope you're watching and paying attention to see how I did it. It's like very, very colorful, but hopefully that makes sense. Sometimes you do introduce a square term. The way I had seen it, I think there was maybe a sign error in the problem that got sent to me. I can't remember right now. But you want to plug those answers in to check, and then just making sure that, you know, things like this, when you square a negative, okay, you get a positive. That's why we got positive m plus 7. right? Because of that squaring of the negative. Anyway, look for those sign errors. And then sometimes, like I said, you will get a quadratic. And I saw that the person who had solved the problem, they got a quadratic. They went ahead and did the quadratic formula to continue. But this ended up becoming a linear equation because of this, the m's cancel. And you can see how making one little sign error can change everything. So that's something you have to be careful about. Okay, well, hopefully I got the right answer because I want to just send this out to you now.